So hello everyone, welcome to today's AI Healthcare Talks Series 2, and it's a Magnimind Academy. Magnimind Academy has been organizing that, and Magnimind has been organizing several events. Last 1 year, we had over 100 events, the workshops, seminars, and boot camps. Free, all are free for the members. It started with the meetup groups. We have over 8,000 meetup members, starting from Silicon Valley and then San Francisco, Chicago. We are in New York and we are in Los Angeles and a couple other places. And we started actually broadcasting all other social media platforms, including YouTube, LinkedIn, Instagram, I believe. There is more than 6 platforms. So now there are people in the Zoom and there are people in the other platforms, but we are taking questions in the Zoom, and our friends can help us to get the questions from other platforms and ask here. We try to answer the questions as much as possible, but if not answer, we're gonna answer in the next meetings. So we're gonna keep doing that. So I like to thank our friends that helped an organization. The NS, April, Thomas, and Hussein worked on this programs a lot. I appreciate their effort, and I should also tell you that the reason we started that AI healthcare talks with this start with the COVID, and I and Chirag is working together in several projects. And that was a lot of lab work we were doing, but with the AI, we were not able to do. With the COVID, we were not able to do it. And we have also other interests in the data science and AI, deep learning. So we thought that it's a good chance to explore what can be done with the AI while everything is in the pause. And we realize that there are a lot of data even has not been discovered, has not been digged. So we see that a lot of opportunities, a lot of trends in the space, and we like to get experts' opinions, and we like to connect the experts and key opinion leaders with the people we've been training. We've been training in Magnimind. We have a lot of data scientists. They are joining our meetings, and they receive a hardcore data science training. And there are people who are joining here is also from healthcare space. I think this meetings is gonna give a great synergy between these two industries, and hopefully we're gonna get something out. So I will start to make introductions. My name is Murat. I'm a co-founder of SmartLens, and also co-founder of Magnimind. And SmartLens, where we're making contact lens for eye pressure measurement. It's electronics free, and we are hoping that we're gonna get millions of people's eye images. That's not only give ideas about the glaucoma. We're gonna find out a lot of things that what eye can tell. And I have friends here with Chirag and Ryan Spitler and Matthew and Chirag and Ryan. We've been postdoc together in the past at Stanford, and we were postdoc buddies. Now we're in different places. Then Chirag is an oncologist, and he's also a PhD in the biomedical sciences, which I always confuse that the department. So, and then he can introduce himself a little bit later. And Ryan is co-director of Precision Health Center at Stanford, as well as Canary Cancer Center. And he's done a lot of research in the biology and medicine. He's gonna talk about his experiences as well. And Matthew is today our guest speaker. He's a co-director of Stanford Center for Artificial Intelligence and Medicine and Imaging. And he's also an assistant professor, clinician science at Stanford Medical Center. And he has several NIH, NSF funded research and he has expertise in AI and deep learning, medical imaging, precision medicine, predictive health outcomes. I think this, like what whoever we have here, is a great resource for everyone who's participating. Hope we can inspire people. And I can start with Chirag if everyone can give brief introduction, and then we can start the questions.
Sure. So like Murat mentioned, my name is Chirag Patel. We did our postdocs together at Stanford, and now I'm a clinical assistant professor in the Department of Neurology with a joint appointment in radiology, focusing on glioblastoma, form of lethal brain cancer. So really looking forward to speaking with Matthew today and moderating, here with Ryan and Murat. So thank you again.
Yeah, and I'm Ryan Spitler, as Murat said, and yeah, we've been colleagues for many years now, and it's been a pleasure working with the guys. And yeah, so I direct the Precision Health Integrated Diagnostics Center at Stanford, as well as the Canary Center for Early Cancer Detection. We handle a lot of data-intensive projects, and we do a lot of work on oncology and other disease areas. And so, we're really excited to explore this space with others, and happy to hear what Matt has to offer today as well. So, thanks everybody.
Matthew.
Yeah, hi. Yeah, thanks for having me, and appreciate the nice introduction. Hi, Ryan. I haven't seen you in a while. And Chirag, I don't know if we've actually met, but it's good to see you too. Stanford's a big place, so I'm sure we've crossed paths a couple times. But
great to meet you here. Yeah.
Excited to hear the audience questions, and looking forward to chatting with you guys about whatever comes up. Yeah.
That's great. I will start with actually the Matthew, and where you have that center, AI Healthcare Medicine Center. Can you talk about this a little bit? It's a great idea, and we'd like to know more about it, what people maybe should hear about it.
Yeah, absolutely. Yeah, I think, we've been pretty lucky. We certainly have a lot of innovative medical faculty at Stanford, but at the same time, we also have a really great resource in folks like Andrew Ng and Fei Li, and a lot of the computer science luminaries that also work here. And so when we very first started the center, it was just simply because of a really wonderful collaboration that I had with Andrew, and working on some early work in this area. And then we started to realize how much fun it was to have a clinical question being approached at by two different points of view, right? The domain expert side, and also the computer science side. And so we started to really try to scale that idea. So we started out with 4 faculty, and now we're up to 120 across Stanford. And really the interesting thing that I think that's really come out of this is that, we have doctors that have, I think initially have been hesitant to try to get into data science or AI, right? But they have found that the opportunity to be as part of a team, very empowering, and being able to contribute something, I think really helps drive these projects forward. And at the same time, we have, 800 students that take computer vision courses every year, right, at Stanford. So these students are looking for good, innovative ideas and data sets, but they don't have that guidance. They don't have that domain, and maybe they're not part of an established lab. And so that's where the scale comes from. And so really just trying to find a way to match a really interesting clinical idea, a data set, and then computer scientists together has really helped us, again, get that economies of scale to really build out our programs. One of the other things we've done a lot is sort of building out bridges to other academic centers around the world. So we have partnerships, data agreements, and we also have partnerships with industry, kind of working on projects that both domain experts and computer scientists can collaborate on. But finally, I think the thing that I'm most proud of is sort of the work we do for open source. We make large amounts of labeled medical imaging data for free to researchers and education communities across the world. We also focus very heavily on making our tools available, so that we can see it go out in the world, maybe get built on, maybe it gets better, it comes back to us that way. And that's been a really fun way to have impact. And so We're up to a little bit over 1 million individual images out there, and we're going to have a lot more coming out soon. And yeah, so that's kind of a nutshell about us.
That's great. It looks like there's a first question asking, could you define what you mean by AI, especially as it pertains to your areas of expertise? And how does AI potentially solve what can't be currently done? It seems like much can be done today. And is that AI's contribution, or is there still room for improvement?
You want me to take that one?
Oh, sure. Yeah.
Yeah. So yeah, I think so. AI, I think, is not a very precise term, right? It's very much a more of a broad term that we use to try to communicate the things that we're doing to an audience. I would argue that some of our most popular work would probably not be considered AI. For example, our Chexpert labeler, which is an NLP-based structured data extraction tool from unstructured reports in order to massively scale labeling of chest x-rays from radiology reports, right? That tool is not, AI in the sense that it doesn't have any deep learning. There's no LSTMs, there's no transformers, right? It's really basically a very sophisticated rules-based system that probably could have been built a long time ago, okay? But I think so using that term, I think, is more to communicate the general idea, and probably is better used in some of the vision work, right? That's where we really see the applications of deep learning as a subcategory of AI is really in its ability to take what is an incredibly memory intensive data, right? Unstructured images, right? And actually come up with a classification, detection, and prediction. And that's probably where that term is best used. But we sort of broaden that, I think, again, for the purposes of communication, just to say that this is something that we are focused on. So, if I use that labeling example, maybe that specific thing wasn't, AI, but the goal is to actually empower the ability to build those tools that would then be AI, right? So you have a large now data set that has labels for training and things like that, if that makes sense. So I guess that's kind of where we're at there. I think the second part of the question was something regarding about what can be done, what can't be done. I could talk for 2 hours and tell you what can't be done, because we try a lot of things here. And probably for every success that we have just as many, if not many more failures, but we learn a ton in that process. And I think that that's kind of how you stay on the edge, right? Is you actually push the envelope and you fail. I think that some of the things that it can do, I think we've tried to show that in some of the work that we've done, but the limitations still are in that implementation, in some of the data set biases that we encounter, certainly in fine tuning for certain populations, multitask learning, unsupervised learning. There's still a lot of different things that we're not 100% ready, probably for any sort of actual deployment. And that's the fun stuff. I mean, for us, we aren't interested in selling anything. We really just want to do great projects that will impact clinical care. And so we don't have that secondary incentive of needing to make a product. But that sometimes can be limiting in the sense that we aren't invested in the user interface and some of the other components that are actually quite important. But we hope that our work will lead to that happening in industry and other groups.
It's really interesting because you're an interventional radiologist. Do you think that there's room for AI in real-time assistance to you when you're performing your interventional procedures?
Yeah, I think that, that's a great question. I mean, we think about that a lot. Certainly with automatic measuring, right? So if I have to place a stent, it would be really nice to know I don't have to manually measure anything. I could sort of get some of that information in real time. In terms of the actual work that I do, I think that would be more in the robotics realm, and maybe that's still under the AI umbrella a little bit, but probably a little bit further away. Although I've seen projects that are moving pretty fast on robotic capabilities in terms of drawing blood and accessing arteries and things like that. So yeah, I think it's all kind of in that sphere, but I don't necessarily see a direct one-to-one as much as I do for some of the early wins, which is sort of looking at the image and trying to make conclusions, at least for now. difficulties there again are just, you're into a robotic space where domain expertise is again another point of consideration. And as a patient, another level of trust, right? When you have a robotic immediate impact into your healthcare, as opposed to sort of maybe a triage tool that's not really necessarily impacting you without a human in the loop. Yeah.
So I have actually a question for you, all of you that are involved in clinical perspective. So how much AI is not being used? There are existing tools, but people are not aware of it. And there's actually a question now that there's some doctors even don't know, or they're resisting using AI in their practice. How much do you think can be used but not being used? Is there a way to improve that? Maybe Chirag or Matt can also, Ryan can answer those if they.
Well, I'm in neuro-oncology, and so we depend a lot on our colleagues in neuroradiology, for example, to help interpret these, brain MRI scans in our patients. And so we're also, of course, able to view and interpret, scans as well. But certainly, our colleagues in radiology have the tools available to do a lot of the advanced processing, visualization. And so I guess one question is, of course, not to obviously replace the radiologist, but then to kind of make their tools available to the frontline clinicians who are seeing the patients, to help them inform maybe at the patient's bedside some of the more sophisticated nuances of the imaging and its interpretation. But I think certainly there's a whole pipeline involved, obviously, getting a lot of this exciting work that's going on with data scientists and basic researchers, first of all, to the radiologist for them to determine whether that actually helps them in their workflow and provides a utility. And then perhaps, down the road at some distant time in the future, being able to provide some of these tools in a very easy way to clinicians who may not be as familiar with the software that's really complicated that radiologists deal with on a day-to-day basis.
Yeah, I think kind of building on what Chirag was saying, I think, not everyone is potentially as capable as Matt, for instance, right? So there are a number of platforms that are becoming available that help, or even with like online kind of marketplaces, essentially, of different protocols or different algorithms that could be applied, that have been validated, that work well, and they can be matched for the application. So, and they even have some measures to kind of prevent incorrect usage, like, you wouldn't want to use this scanner with this algorithm, for instance. So there's kind of a little bit more of a plug and chug involved to make it so even if you're not a very sophisticated user, you could still get some of the benefits of some of the better, well-characterized tools that can be used. And then there's also the ability, as part of that effort, to create things that we develop that work well, that we can make available to our colleagues. So in that process, you kind of create a positive feedback loop where you continually improve these processes and kind of educate each other.
Yeah, I guess in this sense, centers are important. Maybe like one thing related to that, I want to ask also Matthew, maybe after Ryan. So like there is a one aspect how you can get people use this tools that's been developed. And as a center, are you focusing on that? Also collecting data, because a lot of things are related to deep learning. You need to have as much as data possible. Also, another thing is developing tools. So how do you balance all that?
Yeah, you're exactly right. In fact, it even goes deeper than that, because if you look at the entire life cycle, and we'll just use imaging for an example, because every specialty has a life cycle, but in imaging, we have this machine that creates images, right? And then there's a lot of processing that goes on there, and you've seen companies and tools and platforms, and actually even data sets now from NYU and Facebook that can match the pre-imaging information to the actual image that's created, right? So that's a huge area that's very fruitful, being used right now. And that goes to your question of what's being used that maybe we don't even recognize or we don't even know about. That's probably where that's happening the most in terms of this image reconstruction, image acquisition, right? But then there's this piece before the image is even ordered, which is, can we use analytics and predictive modeling and even, again, deep learning to mine the patient's chart, patient's information, and predict the best study for them, whether the study's indicated. There's all those pieces before you even get to the radiologist, right? And then there's this QA process. So there's a lot in the sort of pipeline, and we have to sort of, again, serve as a home base to try to make all these projects possible. We aren't always as successful with some of them as with others. And I think part of that's because of, well, it's data usability, data availability in some cases. Sometimes it's literally, is it being driven by a PI or a faculty that's very interested in that problem? So there's some gaps. I think that the point that you're touching on, though, in terms of deployment usability in a clinical setting, that's actually been a very difficult area for a lot of groups. I think that folks that are relying on commercial vendors have found there are pitfalls and problems with that. People doing homegrown, still problematic. And we haven't yet developed enough of the science to understand how these deployed models will continue to be able to be evaluated, their performance over time, right? Or if I get a new CT machine, to Ryan's point, will it work on that, right? There's definitely things that we are still in the early stages of. I'll also say that I think that in general, we've spent probably less time on that to date, but that is now becoming a thing. In fact, we just finished a giant multi-center trial that will be out soon. And I will tell you some interesting things that came of that. I'm not really going to be able to tell you the results of the trial, but I can tell you an interesting anecdote that might help. We actually had a radiologist that just didn't believe in AI at all, just didn't want any part of it. And so he consistently disagreed with the model every single time, almost on purpose, clearly on purpose. And then until we showed him that his performance prior to the model was, he's making himself worse, basically, right? And over time, there was this eventual kind of, I don't know if he just got tired of disagreeing, but he eventually kind of said, fine, I see where the model's been correct. And his performance went back to aggression to sort of a mean, I guess. And that is a telling thing, right? Because we have no experimental way to know someone's, how are they going to accept it? And everyone has a different opinion of how they want the UI to be. And that's not something academics do very well. And something that we definitely look to our partners in industry and those of you out there, creating new products or working in other groups to really help the field, help us understand how we can display the information from these models in a way that is adopted and actually is increasing performance so that we can achieve what we want to achieve.
Following up on that, you mentioned that a lot of the images, the majority of the images that radiologists interpret are coming from these really expensive, bulky machines that are only available in hospitals and clinics. And with the advent of these point-of-care diagnostics, is there a potential benefit to help, simultaneously reduce healthcare costs to society as well as, allow more access to these types of imaging modalities to others? And what kind of role does AI have in those types of emerging technologies?
Yeah, I love, I guess. I'm a big fan of particularly global health applications. And I'm really a big fan of the idea that you can use, portable, I like ultrasound anyway. I use it for a lot of my procedures, and I just think it's a fantastic modality. And it has so much opportunity, I think, for bringing imaging to the point of care. Like you're saying, reducing those costs. Do we need to send for a giant MRI when we can potentially get some information with an ultrasound, for example? And we've seen some of that already with COVID. The beginning of the talk, we talked about, or you mentioned COVID, and that, we've seen our European colleagues use it quite effectively to look for lung disease, right? And that's not something we typically do here in our practices. And we rely on things like CT and X-rays. And so there are definitely opportunities there. And AI can, again, on the edge, as we're getting good with edge deployment, we can get to a place where maybe these models can run at the point of care with the imaging that you need. That's a really exciting proposition.
So there is something related to that I like to maybe ask Ryan about the Google baseline study where Stanford and Precision Center is involved. So how much of that, what Matt mentioned, that Precision Center is doing in terms of looking at the data or connecting this data with the clinics, could you talk about this a little bit? If you have that deep information on that?
Yeah, I mean, I think, there's definitely, the idea is to essentially have a platform where we can kind of you have all this data aggregated, so we have like the patient data that's longitudinal within the clinic, as well as the data that's coming from, for instance, the study watch, or some of the other measures like saliva or blood-based measures, or some of the other multi-omic approaches. I mean, it's still in the very early stages, and I think we've been collecting the data, but it's still, I think, in the early stages in terms of the discovery phase, and like kind of working some of these things out in terms of which investigators are going to work on which projects, and what are their key strengths, and how do we stitch all these things together. And I think that's kind of part of the goal, and also in terms of having a platform to kind of allow you to have this data like between so many investigators pushing together. So I think that's the goal. I think it's something we're still kind of working on how best to do. And I think as we continually push this forward, we should be able to kind of get a better idea of like, what are things that we could be doing now, and versus what are things that we're still kind of in development for us. I can't get into too many of the exact specifics, but I can give you that kind of overview at least.
Okay, that's good. So I have actually related to that. Matt, you mentioned there is 120 faculty is affiliated with the center. And I'm just wondering if you can break down that, how much of these people are developing the AI tools, how much of them is just providing the data, or some providing the interpretation? How is that working out? Maybe industrial insights as well.
Yeah, no, I mean, so it spans the spectrum, right? There are people that have the ability, they're physicians and they code well, they have CS degrees, they have PhDs. There's a core group like that do incredible work. They run their own labs. There are folks that have had undergraduate degrees in CS or engineering, and they come to the center saying, I now have my clinical domain expertise, right? And I'm looking to sort of get re-engaged in the community. And then I think the majority are, clinicians, either medical school faculty or again, campus faculty who are coming and saying, I'm looking to try to set up a partnership, or I'm learning more about where the interesting ideas are, where the projects are happening. We obviously provide funding. We have Sea Grant programs, we have education, we have labs, lab meetings, and we have all kinds of seminars. So it really becomes kind of a home base in that sense. So yeah, the faculty list really spans the gambit, and has been really exciting, because you've seen, folks that a year ago were just barely getting involved, and now they're, running large projects. So it's really been exciting to see that.
And there is a question from one of the users about whether there needs to be a medical course, or whether exists a medical course about AI in healthcare or AI in radiology, either at Stanford or other universities that students or other trainees might be able to take advantage of.
Well, it's funny you mentioned that. So Andrew Eng worked with one of our former, well, he's still here, but he's going to be moving on. I just graduated his PhD, Pranav Rajpakar. He put together a mini course for those of you that are very technical to learn a little bit more about what applications can be in healthcare. That's on his Deep Learning Day. I don't have any conflicts of interest. I'm just mentioning it. I believe other platforms like Udacity and others have put something together. I have worked with someone named Serena Young and Nigam Shah, Tina Broussard, Lawrence Baker, a group of faculty here, and we've just finished a large course that goes all across AI in healthcare. It's going to be on Coursera, hopefully in the next 6 to 8 weeks. And I hope that, and again, the point of that one is to be both directed towards the clinical and non-clinical audiences, but not get deep into the math and coding. Not quite as in-depth as Jeremy Howard's course, which doesn't obviously require any real in-depth knowledge, but he still, I think, requires quite a bit of coding background to really jump in with 2 feet. This is really meant to be a fundamentals that we hope would be helpful to a med student, any clinician who may be using this in practice, all the way to someone who's ready to start their first project. So, but there's a lot of these out there, and I think that folks are going to start seeing more of it because it is a need and it is a demand. Yeah.
So there's something related to that I like to ask. So as a Magnimind Academy, we're training people on AI and deep learning. A lot of people are interested in just looking at AI healthcare data. But there are a lot of available data, and there are a lot of not available one. but there are good researchers and stuff like that, as you mentioned at Stanford. So those people are really talented, well trained at what we've been trying to do. We're trying to establish collaborations. We have started like around 6 projects with the Stanford and other schools with the Magnimind Academy with the data scientists. So do you have any plan, maybe same for Ryan, for the centers you guys working? Do you have any plan to just maybe have some kind of a database people can help to look at the data and can add the models that they develop? Like one good example, C-Bio portal is collecting cancer data. And this is good. I mean, they're collecting from every different databases, including cancer database. So do you have such plans that as a center or centers have such kind of a portal which our data scientists really can work with the faculty or can work with the data?
I think we don't, like, at least for Find and Canary, we don't have like a formalized portal that has like, it's like for this all-inclusive type of aggregated data to kind of play with. But what we do have is we do have investigators that do create these different types of open source data repositories that would allow for this, either in terms of sharing what they've done, or it depends what, I mean, I think the issue becomes a lot of times the access and what's allowable. So with what they're allowed to do, they certainly share kind of what they're up to, and what, how that might be helpful to others. And I think they welcome any kind of input. So I guess it depends kind of the nature of how deep they want to get into it. I think if it required, depending on what the data is, it might require more formalized collaboration. I think that's kind of why we kind of shied away for such a formalized effort. But definitely, I think the short answer is, I think individual investigators do have that type of opportunity.
Yeah, Ryan, I guess my fault to you would be is what is Google Baseline going to do with all that data, right? They're collecting data on normal patients. They're collecting all kinds of data. Is that just Google's data, or does anyone get to work with that?
Oh, sure. Yeah, so I guess I was speaking to the now. I think in the future, though, so the idea with that is in the future, per committee approval, any qualified data scientist or anyone who can handle the data appropriately will have access to be able to mine that data. So that will be actually an upcoming formalized system that does exactly what Murat was alluding to.
Yeah, that's what I'd heard too. I think that's terrific. I think that's going to be a big benefit. Yeah, I mean, we definitely release a lot of data to the public, which is not easy to do, but is certainly we think valuable. And it's not just that you can't just put data out there. It's also nice to have labels with that are useful. So we do work on that. We host challenges. I think our collaborations with things like the RSNA's efforts, right, around the annual challenge there really, I think has really boosted the opportunity for new data scientists and those who want to get involved in at least medical imaging to have a chance to jump right in, benchmark themselves against both experts and other groups that are competing on these challenges. I think you mentioned at the end, sort of where do these models go at the end? I mean, we've tried initially, we're still kind of learning the best ecosystem for this. This is something I've actually spoken about at length with Jeremy Howard's group at University of San Francisco. But I think the goal here is to really try to figure out an open source ecosystem for pre-trained models of all kinds. Calling it a model zoo, I guess, is the right term here. But that way you don't necessarily have to grab our entire data set, train it, then to, go on to do other things. You can just grab a data set that's already been, already seen that data set, or a model, excuse me. But, for us, we're moving towards a larger, but mainly open source, not some sort of like gatewayed access. I think that's really important for us to make sure that folks can actually have the data in their hands, because that's how at least people that are just getting started in this field tend to learn the best.
There's another question from the community asking, how important is it to express uncertainty in medical AI? How much emphasis and research is going on into this area? Is the current progress in neural network uncertainty sufficient or lacking from it? And then similarly, how much effort is put into explainability for medical AI?
Sure, I can take that. Yeah, so yes, it's extremely important. we've actually, depending on the application, but we've learned a lot from other industries that have done this for decades, right? Where they look at, and this comes down to kind of a sort of what I alluded to before, a human-computer interaction question, right? So if you look at the airline industry, if you have a pilot that has a million warning lights, what you need is that pilot to not just trust the system. That pilot needs to know what the confidence of that system is in what condition, right? And so they've done many different simulations on this, where if you don't provide a confidence, the automation bias kicks in, and the human user ends up siding with the machine, sometimes even when the machine is obviously wrong. And that's been shown in all kinds of different areas, right? So that's a big problem in medicine. We don't want to have a situation like, you're following your GPS and you drive it into the train tracks, right? You don't want that. So what we've found is that by providing a calibrated and accurate confidence, and that's the key, that can actually give the user some understanding of the model's confidence, that would help the human make a better decision as a unified group, right? Because you're not trying to deploy these as autonomous systems. And so, yeah, that's very important, but it's also important for those of you out there who are, in the machine learning world, to say that just because the model's probability is, 70%, that doesn't necessarily have a real world anchor, right? That's just the model's sort of understanding of the training data set. So understanding that you still have to do some investigation on where that real world applicability lies, that's important. But that all is in explainability, and it's a huge area of interest for those in the medical community. Yeah.
Now, there is another question which I agree with. There are a lot of difficulties with different data sets. So, like even sequencing data, like 10 years ago technology versus now, people may have done like a 10,000 samples, clinical samples, versus now it's all with new technology. Same thing with the new MRI devices, new technologies. There's a lot of like gaps between technologies and data sets. So, but you like to see all data together. What do you think about that? So, can there be a way that can maybe normalize all these technologies or data sets?
Are you talking about basically multimodal data, right? Yeah. So that's my personal lab's interest, right? We work really hard on hybridizing. So we're really trying. To Chirag's point earlier, we are trying to replace radiologists. I mean, I don't know if we're going to do it, but we are, right? Because that's the goal, right? Why are we doing this if we aren't trying to get to the gold benchmark, right? But we're allowed to do that because we're in academics. But in order to do that, we understand that the workflow of a radiologist is to look at the patient's information, which it comes in an Epic chart or whatever electronic medical record. You look at the vitals, potentially you at least look at the diagnoses the patient may have had. Then you make your decision. You don't make it in a vacuum on just one image, right? You sometimes look at prior. So all that information has to be accounted for. And so we've looked at data fusion techniques, and there is a lot of this going on in autonomous driving, but without going into this in too much detail, there's early fusion, there's, sort of joint fusion, there's late fusion, there's different ways, and late fusion is really just ensembling. But in other words, what we want to do is we want to train models that can incorporate different modalities and bring that together to make a better prediction, a better decision. It doesn't always work, but we believe that that's going to be the next frontier, because if we continue building models that rely solely on the image in front of them, it will ultimately be limited forever, right? You'll never ever break out of that box.
So I think, Matt, that's great. It's better coming from you than from me in regards to replacing radiologists.
Yeah, you're not allowed to say that, but I can say that.
But maybe it's just a matter of reframing it to like talking about, it changes the role of what a radiologist is, with the assistance, from AI. And so it maybe makes it more palatable. But another question is, when we talk about AI, some people consider it to be like a black box where you don't really know how these neural networks are getting to the answer that you're, for the question that you're asking. And so let's say that there is some kind of algorithm that, does a really good job at answering the question that you have, but you may not understand how it works. What would you do with that? Would you use it? Would you try to query how it's getting to that conclusion? Or do you just say, this is answering my question for my purpose, and I'm going to go ahead and use it.
Yeah, it depends on the use case and the doctor. I think that there's a lot of debate about this that's been going on for a long time, right? Because there are clinical risk scores that become very complicated, right? That eventually you get to the point where the doc that's using that scoring system doesn't really necessarily understand all the different factors that are maybe going into that. But for the most part, I think that we would like to understand where the decision's being made, especially to make sure there's no bias, right? So I think there's a lot of effort in that. I have heard debates. I've been on panels for these kinds of discussions where, some physicians would argue that we've been using different medications for a really long time that we don't totally understand how they work. And yet we still use them. So based on just the results, right? Not based on the intricacies of the pharmacodynamics. So I'm not sure I fall on one side of that debate or the other, not to split the middle here, but I feel like for certain use cases, even as a radiologist, I would really need to know, particularly because I've seen so much go wrong with bias, that I need to know why the decision is being made, at least to the development point. Maybe in deployment, there's some wiggle room there, but yeah, I think explainability is really important. And I think that the work that's going into that is going to be very helpful for the future.
Yeah, actually, I have what I do is I go through the questions as well. I'm summarizing some of the questions as much as it fits in our discussion. Something I like to ask everyone that I feel like in some field is the AI is not appreciated much, but in some field is kind of a oversell in different areas. So just because it's buzzword, every startup use, every lab use, but a lot is not related to AI. So do you have any an examples that some fields is really needed but are missing? Some field is just, okay, it will maybe develop with time. I can see that in radiology is one of the most common applications people use, and radiology the mostly. Maybe the pathology is also some people give an example, but there may be some areas that people still may need to implement AI.
Yeah, I mean, I'll take this. I guess I'm happy to just sort of opine on it. I think that there's, I think we are increasingly using these technologies in our daily life without really understanding or knowing that. Just as if I took off my, I'm a Stanford academic hat and just became a normal, guy walking around, half of the things that I do with my phone and all of these other things, these are all built on my Google searches, my banking, all these things are built on algorithms that use some of these same tools and principles, right? So there's an aspect of this starting to creep into a lot of what we do. And as we continue to, so any area that has, large data, is generating large amounts of data, generally, I would believe can be automated in some way. I think Andrew always says that if something can be done in, whatever, 10 seconds or something by a human, that can potentially be automated. But doing it and having it provide value are sort of two different things. And again, as I mentioned earlier, I think coming from academics, I sometimes can be faulted for not thinking as hard as I should about maybe the implementation piece, because we're really just trying to do the discovery, I think, in a lot of what we do initially. And now that we're in this phase where we are looking at implementation, I think that we're still exploring where the best early use cases are going to be. And we found a lot of that in reconstruction. We've certainly seen a lot of that in early classification, but there are many areas across medicine that I think they're going to be discovered because we're bringing more people into the fold, right? We're bringing in our anesthesiology colleagues and our cardiology colleagues, not just radiologists, and asking what in your practice can be helpful, right? And that, I think that's where the value starts to come, is when they're bringing ideas from the domain experts.
Just a quick follow-up on that. There's one interesting question here about if there's any work being done in regards to AI in dentistry. And are you aware of any of that kind of work going on? And what potential applications there are?
I'm not as familiar with I know that dentistry, and actually even more recently, I've been seeing a lot of work being done in veterinary right? Because they have pathologists, they have radiologists, and they're in short supply. They generate lots of data. They don't have regulatory issues as much as we do, right? So you could probably deploy an algorithm at a veterinary clinical practice tomorrow without having to go through all the FDA kinds of hoops that we tend to do. So I think I think there's a few startups in this space. Certainly dentistry, I'm not as quite familiar with. I don't know whether there's a huge value there or not. I'm really not familiar with that clinical workflow.
I can add to that one, because I'm advising a startup which they're working on taking pictures of the mouth and teeth, and then they wanna send this to, they wanna pass through the AI and send it to the dentist. And after they took a lot of dentists, and a lot can be done just with looking at the images, and then not need to go to dentist. But it depends on certain diseases can be identified with it. I see that there are a lot of space in there as well. So I have actually one question that I like to ask everyone as well. That's I like to also get your insights for our participants as data scientists, what they should be looking into it. Do you have any imagination or vision for like 20 years from now, some technology that you're imagining that will really change everyone's lives? Do you have like any futuristic thoughts on that?
Well, I guess one thing that we kind of think about oftentimes, like we culminating all these different aspects, and so we think of it. You mentioned like airplanes. We think about like the digital twin. So like something where you could have basically a digital twin of yourself, and then have the imaging, the multi-omics, have everything about yourself, risk profiles, and then that's kind of like the vision of our centers, be able to understand the healthy, to look at disease progression, utilizing a model that's complex, but then very individualized to each person. So obviously this isn't something that overly practical, but since you kind of had like a big future vision, that would be something that, we really like to try to create in the future at some point.
I think along the same lines, when we talk about our different disciplines in medicine, we have radiology, pathology, oncology, for example, or medicine, and they're kind of working in sometimes a stepwise or linear process. And so the idea is that if we can really leverage AI and use a scan, an MRI scan or a CT scan, to understand what the pathology might be without even having to get a piece of the tissue, or understand the genetics from what the characteristics of the tissue, especially for areas in the body that may be hard to access or risky to access in terms of undergoing a surgery, or for a patient that can't undergo a surgery for other reasons. Could we use the imaging to really provide us the information we need to kind of start treatments much earlier without having to go through a lot of the kind of procedural yet important, steps that we plan right now as our workup for a patient. And so I think that's another kind of exciting realm to consider. But again, it's a whole idea about, retraining the future generations in these disciplines, not to do away with, radiology, pathology, et cetera, but to kind of say, well, what is the new role in the setting of the presence of AI?
You guys are thinking short term. I'm thinking I'm thinking big. So like I want to replace all specialties with one doctor. I want to say that you can have you can codify specialty knowledge, and Elon Musk style, do implants. Let's get that augment a human in a way that's never before been possible. And that's where we need to go, right? We need to create one person that has the entire specialty somehow codified and have that would be a cool vision for me. I think that as we're building these things that we're all doing and individually, I think we're building expertise into our models, right? We're building specialized expertise. how do we then bring that to the human and make that really that marriage really possible? That would be super cool. I would love to volunteer for some matrix-like implants for for that. But I really want to see that be something that we shoot for in the next few decades.
Yep. I agree, Matt, that I also envision that, like, when there will be in 20 years or 30 years from now, technology will track us. They're already doing it. If you look at, there's a Facebook portal we have at home. There's just the camera is following you. There's
That's
Alexa's
scary.
and
I do
others.
that one.
So, and then Google baseline study give you these devices can track your heartbeats and others, and even your EEGs and stuff people may track. I feel like in 20 years, all our daily life will be recorded, and then we'll get warning at the end of the day. Oh, you have some concerns in the heart or brain and cancer. I believe we'll see that in not very long future. It's going in that direction. So there are questions, and we have limited time, and maybe Chirag can maybe wrap up some questions, and as well as Ryan. And
there's a series of questions here from some of the users about data security. I think Matthew kind of alluded to this earlier with the large data sets. That of course the goal is to annotate them and make them publicly available. Obviously, data, make sure that there's no potential for tracking directly, which no patient. What are some of the standards that are being used in these large public data sets that are being made available through Stanford, the RSNA, the NIH, et cetera?
Yeah, it's actually, we all use the same process, and we followed the NIH lead on this, and the NIH does something a little different than what we've done. The NIH is putting it as a Creative Commons license, which means that even a commercial vendor could use it and make a product out of it. We restrict that. We say it's only for research and education. And this is because of legal reasons that we really aren't going to be using this for someone to then go out and sell, right? We don't have ethical permission from our patients for you to make money on their data, right? So that's where we draw the line. But in terms of the process, it is de-identified, but then it's every single image is manually reviewed by a human. And that's also what the NIH does. And that's what makes it difficult and expensive to do this. We still think the ROI is there, and there are better processes. In fact, the NCI and it's called the TCIA, the Cancer Imaging Archive from the NIH. They have an incredible amount of tools, and that's coming from the University of Arkansas, who really started this whole thing, where they're able to review that manually in a very much more efficient way. So I think as we go forward in the future, we're getting, especially with COVID, a lot of energy around sharing data and making data available for researchers. And I think that seizing on this momentum, building platforms and pathways to do this collectively with a lot of institutions for this COVID initiative at the RSNA, we have over 200 institutions sharing data. We're going to get to a place where I believe that this barrier will be eventually broken down. A lot of it's just related to people being unsure, not really understanding all the limitations, sometimes thinking their data is super valuable and they want to sell it. There are all kinds of different, agendas, right? But at the end of the day, the best use of our patients' data after we've used it to take care of them is to make it anonymous and then also make it available for further research to advance the field. That's at least our position on that.
So people asking Link about different data set. Actually, we are using CBio portal for the cancer data set. I recommend that if you want to start from somewhere as a data scientist. But there is also TCGI, but CBio portal is also extracting data from that and other places.
Yeah, and you can go to RSNA has the data sets from the CAGO challenges, and then at our AMI website, amy.stanford.edu, we have all of our data sets available there as well. Yeah.
Yeah, actually, we came to the end of the discussion. We have a lot of questions. We keep those records for the future. Also for Magnimind Academy, some of those very specific technical questions, we have workshops on it. I highly recommend to follow up one of our channels. It may be Meetup channel. So we have these meetups on certain technical. We are starting a lot of AI healthcare workshops. I highly recommend that. And we have also collaborations start with Stanford Labs and University of Illinois Labs. And I can refer the rest of the question, the future meetings and our future workshop. So I like to thank Matt, Chirag, and Ryan. It was very insightful discussion, and we're just gonna keep working on it. Try to deliver good environment for the data scientists and healthcare professionals. Thank you.
Yeah, thanks
Thanks
for
a lot.
having me. Good to see you guys.
Good to see you. Okay, take care.
Bye.
Bye.